There we go. Okay, so what do we have a quiz on Friday? To be honest with you, I think Friday is a little early, but what I would like you to do is I would like you to give it a try on Friday, and if it ends up being more of a practice quiz, then that's okay. Do you know what I mean? Because I think I wish there were a Saturday and then we could have like a 3-day weekend after that, because I think that would be the perfect day to have it on, but that's not going to work. So we are going to have it on Friday. Okay. And we will have learned everything. You may or may not be ready for it, which is okay. All right. But I want to see where you are at, and I also want you to study for it. Yes? And then if you totally knew what you were doing, you have your weekend free, and if you write the quiz and you're like, oh my gosh, I didn't know what I was doing, then you know you need to study a bit more over the weekend. All right, we are now on page 99. And last day we were making two kinds of ions. Tell your partner, what were the two kinds of ions we were making? We were making cations and we were making anions. Which ones are positive and which ones are negative? Cations are positive, anions are negative. Which ones are made from metals and which ones are made from non-metals? Cations are metals, and I added a little metal tag to our cat here. Yes? So there's metal on its little tag attached to its collar. So that reminds you that cations are formed from metals, and of course, non-metals start with N, and they form negative ions. If you are forming a negative ion, are you losing electrons or are you gaining electrons? Gaining electrons, because you're gaining negative things, right? And if you're becoming positive, you are losing electrons. And remind me, why are these things bothering to gain and lose electrons? Why do they do it? Tell your partner, why do atoms want to gain or lose electrons? Okay, do we remember? Yeah? So we need to, why do they gain or lose electrons? Because they want to be not quite balanced. They want to be stable. Which means, are they going to be at high potential energy or low potential energy? Stable, low potential energy. And what kind of a shell is very stable? What kind of a valence shell is very stable? a full or empty, because if it's empty, then the next in shell is full, okay? So if we have, like in this magnesium ion, is magnesium a metal or a non-metal? Magnesium is a metal. Almost always, if you hear that ium ending, it will be a metal, okay? So that's a metal. And if we look at its outer shell, how many electrons are in its outer shell? 2 electrons. 2 electrons in the valence shell. Is that closer to full or closer to empty? It is closer to empty. Yeah. Yeah, so once the electrons are gone from the valence shell, we don't bother with calling things valence shells or not anymore, because the whole word valence has to do with whether the electrons are involved in bonding to other atoms or not. So if magnesium, if it has 2 electrons that get involved in bonding and we empty it out, now our valence shell is empty. Yeah? So the next shell in is not really the valence shell because those electrons are not involved in bonding because they all have little partners. Okay? Yes. I can scroll up a little bit. Yes. Here we go. And in fact, I can make it so we can see everything all at once. Okay, so the diagram on the right-hand side, we are going to be going from our neutral magnesium atom, and we're going to now turn into an ion. And what is an ion? An ion remind each other, and then I'll call on you, Adri, okay? What is an ion? Adri, what is an ion? It's an atom or a group of atoms with an electrical charge. have our magnesium atom, our neutral magnesium atom. How many protons are in that atom? 12. So that is 12 positive things. Go and count up the electrons. How many electrons are on that atom? One, two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 electrons. That means we have 12 negative things. And what does that tell us about the positive and negative charges? They cancel out, they balance out, so the overall net charge is 0. Okay, remember that net means overall. What is the symbol for magnesium? Mg. Did I do that correctly? Has to be a capital M, yes. Okay. When an atom turns into an ion, does the protons change? Do the protons change? No. So we still have 12 protons, so 12 positive things. Now, if you remember, over here we had 2 electrons in the outer shell. We're either trying to fill that shell up. How many electrons would be needed to fill that shell? That outer shell that has 2 electrons in it. You would need 6 more to make 8. What's going to be easier, gaining 6 or losing 2? Losing 2. So, as we go from the atom to the ion, we lose 2 electrons. If we lose 2 electrons, remember we're losing positive stuff or negative stuff? We're losing negative stuff, so what's the charge going to be? Positive, and it's going to be positive 2. You can write it either as 2 plus, or you can write it as Mg plus 2. Either way is fine. Let's see if that works with our protons and electrons. Now, when it loses 2 electrons, you'll notice I have to now cross these out because my drawing had them in there, but I need to cross them out and say they're gone now. Gone. Gone. So how many electrons do we have now? 10. What is 12 positive and 10 negative? Plus 2, or 2 positive, which confirms we lost 2 electrons. That gave us a 2 plus charge. And if we look at our protons and electrons, that also gives us a plus 2 charge. Doesn't matter which way you find it, both work very well. Oh, and what happens to the name? We only did one example yesterday, so I'm not surprised if you don't remember. Metals do not change their name. Metals do not change their name. And look at this. We have the little cat collar with the metal, and it says the name. Does the name change? No. Because if your cat is named Fred, they will not come when you call Tinkerbell. Come here, Tinkerbell. Right? You can't just change their name because their name is their name and they know it. So metals do not change excuse me, the name. So what is the name? Magnesium. Okay. Do we want to do aluminum together, or do you want to try aluminum on your own? You want to try it on your own? Why don't you try it on your own, and then I'll do it, and if you need to do it with me, you can do it with me. Okay? Try it on your own, though. Give it a try. All right. How are you guys doing? Do you need another minute to finish? Another minute? Yep. So here's a good way to check your work. You can say, I know that aluminum, I can go look on the periodic table. It is to the left of the staircase, therefore it is a metal. If it's a metal, what kind of ion is it going to form? It's going to form a cation, and cations are what charge? Positive. And so that means when I have my aluminum ion, there's going to be a positive up in the right-hand corner. And if I have a positive charge, have I gained electrons or have I lost electrons? Therefore, we lost electrons. You see how I'm kind of working it backwards this time? Okay, so you can work forwards, you can work backwards, you can check your work by doing that. So what that means is we lost electrons, right? Because we're a positive charge, so we had to lose electrons. How many electrons are we going to lose? 1, 2, 3. Beautiful. So we lost 3 electrons. So what am I going to do with those 3 electrons over on the right? I'm going to take them out. If I could erase them, I would, but you can't print something and then erase it. So gone. Yeah, if it's actually, if it's less than 4. If you have 4 electrons in the valence shell, sometimes people ask me about that. You know, if you have 5 or more, you'll gain. If you have 3 or less, you will lose. If you have 4, they don't actually either give or take. They will share their electrons with other atoms, and we'll talk more about that in unit 3. Okay? All right. So those 3 electrons are gone, and if those 3 electrons are gone, what is the charge? Positive how much? 3, because we lost 3 electrons. And it's a metal ion. Do metals change their name? No, so we know it's aluminum. And we can go and we can look up aluminum on the periodic table if it didn't tell us already that there are 13 protons. 13 protons. And we have how many electrons? We have 14. No, what am I doing? Why am I circling neutrons? What a crazy woman. Ah, okay. How many electrons in the aluminum atom? 13, because they have to be the same, because in an atom, the net charge is always what's the net charge in an atom? Always 0. Okay, so the net charge of an atom is always 0. So if that's the case, we now have Al, and then we have, is there anything up in that top right corner? No. And then over here, we're going to have Al. We lost 3 electrons, so how many electrons do we have in total? 10. Okay, whoops. Hey, go away. Control Z, Z, Y. There we go. Okay. And so our net charge, we have 13 positives and 10 negatives, so our net charge is +3. Now, I'm going to remind you of a couple of things that we've probably forgotten. This aluminum atom has 13 protons and 14 neutrons, okay, because it gives us the neutrons here. What is the name of this aluminum? This would be named aluminum what? We have 13 protons, 14 neutrons. What do you do with the 13 and the 14? You add them together because the mass of a proton is 1. The mass of a neutron is 1. So if you have 13 protons, you have a mass of, hold on, if you have 13 protons, how much does that weigh? 13. 13 what? AMUs. And if you have 14 neutrons, how many AMUs does that weigh? 14. So 13 protons and 14 neutrons gives us 27, and the unit is AMU. And if I wanted to add that onto the aluminum name, where would I put that 27? I would put dash 27. And if I wanted to write the symbol, the isotope notation, where would I write the 27? At the top or at the bottom? The 27 is going to go at the top because that's the mass number. And what number goes down at the bottom? You remember what number goes down here? That is the atomic number. Okay, so the atomic number goes down at the bottom. And so what is the atomic number here? 13. And do you remember why that's nice? Because if you go to find the number of neutrons, you take 27 and you subtract 13. So this is the atomic number. That's the symbol. That's like the full isotope notation. Okay? You don't always have to do that, but if you're asked for it, that's what they're looking for. That's called the isotope notation. So we could actually do the aluminum ion the same way. The mass number goes, where does the mass number go? At the top or the bottom? At the top. What number goes at the bottom? Atomic number, so that's 13. And then when we have the ion, it also has the 3+. Is good? Now, is anybody confused about where any of those numbers came from? All right. Okay. So let's make sure. Let's make sure that we can, yes. Yes. So where do these extra electrons go when they get chucked out of calcium? Where might they go? They go to other atoms. Now in this next example, we've only shown the outer shells because it gets cluttered otherwise. And sometimes we will only show the outer shells. Is sodium a metal or a non-metal? Tell your partner. Sodium, metal or non-metal? Sodium, go look it up on your periodic table. Where is it? Yeah, if you're having trouble finding it, you can always use the alpha listing. And we can go sodium is atomic number 11. And so we go 3, 4, 5, 6, 7, 8. Oh, there's atomic number 11. So is sodium a metal or a non-metal? That's a metal. Everything on the left is a metal. So we have our metal. How about chlorine? Is chlorine a metal or a non-metal? Go look up chlorine. Where will we find chlorine? Okay, so sodium is over on the left. Chlorine is over on the right. So sodium is a metal, chlorine is a non-metal. Do metals gain electrons or lose electrons? They lose electrons. Do nonmetals gain electrons or lose electrons? They gain electrons. And so isn't that nice that sodium loses and chlorine gains? Because then one is losing and one is gaining, and you have to have that. So whenever you have this type of bond, and it is a chemical bond that's forming, where one atom is giving to the other, it's always a metal giving electrons to a non-metal. Okay? Oh, by the way, sodium is not just a metal, it's in a specific group. Do you remember what group it's in? Tell your partner. What group is sodium in? Sodium is in the, Max? Alkali metals. And chlorine is not just any old nonmetal. Oops, I forgot my I, alkali. Alkali. What group is chlorine in? Second from the right. Halogens or halogens? Doesn't matter which way you pronounce it. I have a tendency to say halogens, but halogens is just as good, okay? All right. So a metal gives an electron to who? The nonmetal. So we've got this electron here. Where is it going to go? It's going to slot into that little empty slot. And you'll notice that sodium now has an empty valence shell. And chlorine has a full valence shell. And the thing we know about empty valence shells and full valence shells is they are very stable. So nature's like, ooh, I like being like this. And then guess what you have? You have a sodium ion. And what do we call that Cl- ion? We call it a chloride ion because the nonmetal changes its name, the metal does not change its name. So we have a sodium ion and a chloride ion. Together they make sodium chloride. And do you guys know what sodium chloride is? Table salt, yes indeed. And guess what else? You have positive sodium atom, or ion rather. You have a negative chloride atom. What do positive and negative do? Positive and negative, they cancel each other out, but they also attract. excuse me, so you'll end up with a sodium ion and a plus stuck to the Cl minus. Very rarely will you have a single sodium atom and a single chlorine atom. You'll most likely have a whole bunch of sodium atoms and a whole bunch of chlorine atoms. And eventually what's going to happen is all of them will turn into ions, and you'll have the silver is sodium, the green is chlorine, sodium, chloride, sodium, chloride, sodium, chloride, sodium, chloride, sodium, chloride, sodium, chloride, sodium, chloride. And they alternate, plus, minus, plus, minus, plus, minus, because what does plus like to be beside? Minus. And what does minus like to be beside? Plus. So if you look at this sodium here, it's positive. What is right beside it? Negatives. Okay, and then you only get to another positive on the diagonal, which is further away. So it likes to be like that. All right, so we now have Bohr models of ions. To draw Bohr models of ions, you are going to draw the neutral atom first. This is on page 100. Look at us go. So I don't care if you want to draw a neutral atom or an ion, you are going to start by drawing the neutral atom. It will make your life easier. Once you get really good at it, you can go straight to the ion, but I would recommend for everyone, what should you draw first? Neutral atom. What Bohr model should you draw first? Neutral atom. Everyone, what Bohr model should you draw first? The neutral atom. And if we draw the neutral atom, what do we know about the protons and the neutrons? Or sorry, electrons. The protons and the electrons are equal. So we're going to draw the neutral atom first, and then we'll turn it into an ion just like we were doing earlier. First shell, how many maximum? 2. Second shell, how many maximum? Third shell, how many maximum? 8. Do you remember the order to put them in? Okay, so we start with the closest shell to the nucleus. And we go 1. Where does number 2 go? Right beside it, 2. First shell is now complete, full, whatever you want to call it. Where does number 3 go? Three goes at the top. Then where do we go? Side, 4, 5, 6, and we're dealing with oxygen here, and oxygen is atomic number 8. So we have 3, 4, 5, 6. Now we go to 7. Now we start pairing up, and we have 8. So what this is going to look like, this is oxygen 16. If it is oxygen 16, how many neutrons do we have in oxygen 16? 8, because 16 minus 8 is 8, okay? So 8 protons, 8 neutrons, 8 electrons. That is a neutral oxygen atom. Is oxygen a metal or a non-metal? Non-metal. Therefore, will it become a positive ion or a negative ion? It's going to become a negative ion. Does that mean it's losing electrons or gaining electrons? Gaining electrons. take a look at that outer shell and decide how many electrons it's going to gain. Remember, you can always draw in a little box wherever you see a gap. Oh yeah, for sure. Is that better? Thank you for asking, I appreciate that. Other people will want that too. Okay. How many gaps are there in the neutral oxygen atom? 2. There's one, we've got an unpaired electron here, so there's a gap. And we have another unpaired electron here, so there is another gap. We have 2 empty slots. So what is oxygen going to do? It is going to gain 2 electrons. So we are basically, let's see, do I have it drawn down here? Yes, I do. Oh, look at that. Here's our 2 empty slots, and we're going to throw an electron into this one, and we're going to throw an electron into this one. Where are those coming from? The electron is coming from a metal. Okay. So now we have an electron here. We have an electron here. We've gained 2 electrons, so what is the overall charge? Negative how much? Negative 2. So what we're going to do, and this is the last step, you have to, and I'm going to get you to draw them on, so go over the brackets with your pencil or your pen. Word will not let me do square brackets. They're actually supposed to be square brackets, but I would have to use line segments to make them, so Word will easily let me do kind of curvy brackets, but there actually should be square brackets. You put square brackets around it, you're saying this entire Bohr model, this entire thing in the brackets has a 2- charge. So that is the Bohr model of an oxide ion. Do you see how if you know what the neutral atom is first, you can easily sort of add in electrons or take away electrons to make the ion? Yeah? So let's just summarize in here. To form an ion, we either add electrons or remove electrons. So the ion has a full or empty what shell? Valence shell. If an atom has 5 or more electrons, will it gain or lose electrons? It's going to gain electrons. Is that going to fill or empty the valence shell? Fill. And adding electrons makes the ion positive or negative? Negative. And what kind of ion is negative? That's what do we call a negative ion? An anion. So what kind of elements will do this, will gain electrons? What kind of elements do this? Nonmetals. What's the last step you should do when you draw a Bohr model of an ion? You need to put the brackets and what else? The charge. So you're not finished drawing a Bohr model of an ion until you have put the brackets and the charge. Okay, let's try the next one. An atom that has 3 or fewer electrons, is it going to gain or lose? It will. You can use the washroom. But first you have to tell me, if they have 3 or fewer electrons, will they gain or lose electrons? They'll lose electrons. Yes, you may go to the washroom. And if they lose electrons, are they filling or are they emptying the valence shell? Emptying. To empty the valence shell. And if it gives away electrons, that makes the ion what charge? If you're giving away negative things. Is that positive or negative? Positive, yes. And if we have a positive ion, what do we call that kind of ion? That's a cation. And what kind of elements make cations? Metals. So here's calcium. Heaven help us, right? This calcium. Thank goodness we didn't have to draw all the dots ourselves, right? That's a lot of dots. But the important part is its outer shell. It has 1, 2 electrons in its outer shell. Will it gain or lose electrons? Lose. How many is it going to lose? It's going to lose 2 electrons. So what are we going to do over here to show that we have lost those electrons? You can either erase them. I can't erase them because I can't erase on here. But if you do draw them, you have a choice. If you're writing in pencil, you can erase them. If you are writing in pen, you can cross them out, okay? Now, should the brackets really be curved like this? No, they should really be square. And they don't have to be thick like this. I'm just trying to go over the non-square part. Okay, they can just be single lines. So you have to put the brackets and what else? The charge. Brackets and the charge. Don't forget those 2 things. Remember that a full or empty valence shell is very stable, and therefore it has a very high or low potential energy. Low. If an atom has 4 electrons, don't worry, it won't lose, it won't gain. What will it do with its electrons? It's going to share. We'll talk about that later. Okay, so don't ask me what the charge of carbon is. It very, very rarely forms. This is what it looks like when they share. Their orbitals sort of overlap with each other. Okay, but we don't need to know that right now. All right, you are going to try these out. Now, let's do the beryllium ion together. What do we mean when we say group name for beryllium? Let's go find beryllium on the periodic table. Where is beryllium? Right there. Beryllium is in group number 2. Tell your partner what we call all the elements in group number 2. Those are called the is it the alkali earth metals? alkaline earth metals. Whoops, EARTH. So here we go. They're the alkaline earth metals. What group is beryllium in? Beryllium is in group, let's go look at our data pages. It's in group 2. Now, hang on. While we're on the periodic table, what period? It's in period 2 because this is period 1, this is period 2, this is period 3. Okay, so it's in period 2 and in group 2. So let's go back. It's in group 2. It's in period 2. We cannot give the mass number yet until we go up here and we look at the information at the top. We know that the atomic number is 4. What else does that tell us? Atomic number is the number of protons. So protons equal 4. And we're told that neutrons equal 5. Another word for mass number, it isn't really another word for mass number, but mass number is the total mass. So what's the total mass of beryllium? Protons weigh how much? Each proton weighs 1. Each neutron weighs 1. So how much does 4 protons weigh? 4. And how much does each neutron weigh? 5. So what's the total mass? 9. So what's the mass number? 9. Because the mass number just is the total mass. Okay? So now we can go down and we can say that the mass number is 9. And now we are actually going to draw a nucleus. And in our nucleus, I know, I'm so sorry. I should really put in circles for you. I'll work on that for next year. It'll be too late for you, but the next group will thank you for complaining about it. How many protons go in the nucleus? 4. 4 protons. How many neutrons go in the nucleus? 5 neutrons. And remember, are you going to start by trying to draw the ion, or are you going to start to try by drawing the atom? The atom. How many electrons in the atom? 4. So we're going to go, okay, here we go. We have 1, 2. Where do the next 2 go? Top and the right. 3, 4. So that's our beryllium atom. Start with that. How do we turn it into an ion? We're going to take away 2. And you know what I'm going to do? Because I've got an eraser, I'm going to, look at that. Now, if you're like, wow, that's way too much work, or I wrote in pen, what's the other way to do it? You can just cross them out. But if you've got an eraser, you can just erase it. You don't even have to erase the circle, you could just erase the electrons. Yeah? So up to you whether you cross them out or whether you erase them. And now, what's the last thing you have to do? Now it's an ion, and it lost 2 electrons. So keep track of how many electrons it lost, right? Sometimes that might be nice. That might be a good reason to have it there. You can be like, okay, it lost 2 electrons. I can actually see that, which makes it a little bit nicer, right? What do I have to do for my last step? Brackets. And maybe I need to write lost 2 electrons somewhere else because that's taking up space where I need to write something. What do I write at the top right-hand corner? The charge. And since we lost 2 electrons, what's the charge? Is it 2 minus or 2 positive? 2 positive, because we lost 2 negative things. So do you guys think it would be reasonable to do page 102? Well, let's see, how many? 103 and 104? Or actually, no. Let's do, why don't you do the odd numbers? Yes, that'll do half of them. So do the odd numbers, do number 1. So those are the ones on the left. And then you can do more practice if you need to doing the ones on the right. Does that make sense? So do the ones on the left. 1, 3, 5, 7, 9. Okay. 1, 3, 5, 7, 9, 11. Okay. So pages 102 to 105. Do odd numbers. Number 1, 3, 5, 7, 9, 11. Is good? So basically 1 to 11 odd numbers only. Now, if you're wanting to work ahead, feel free to like dip into whatever comes next, okay? Because if you actually understand this, it shouldn't be too difficult, all right? But we will be going over it next day. Yes? What about ions? I'm going to come closer because all I can hear is the word ion. Oh, the ion symbol. Sorry, I forgot the ion symbol. Yeah, don't forget the ion symbol for beryllium. It would be Be 2 plus. There we go. No, that is totally a typo. Yes. Yes, oxygen should be 8. And remember, oh my gosh. Oh. Yeah, we already did magnesium. So oxide, we will have 8. If you're doing number 12, because I know some people are working ahead. So if you're doing number 12, there is a typo. You're going to look, if you're doing number 12, and in fact, all of you could make this correction if you want to, or I'll let you know again next day. The atomic number is 8. The number of neutrons, I'm going to make it 9. I don't know if that matches with the answer key, but we'll pretend it does. Yeah. What's that? Yes, you may.
Thank you.
Absolutely. Good stuff.
And one last question. I know
Yes.
midterms are coming up. Do you think I'll be extending or proficient so far?
So far, I think you're very high proficient. Very high proficient. So like on the border almost.
All right. Yeah,
Okay.
I'll take it.
Yeah.
Thank you, Miss Hunt.
You are welcome. Yes.
So it's a gas,
Yes.
and if I add two, then that will make it negative.
Yes.
But it's a gas.
But it's a nonmetal, and nonmetals become negative. Gains 2 electrons.
I mean,
What are you doing?
oh wait, I'm just lost. I got.
It's okay. You got it. You got it. You got it.